Hi, I'm Justinian. I'm the project manager of Rover from the Technical University of Cluj-Napoca. Our rover was developed for the European Rover Challenge 2026. As the project manager of the Rover team, my role is to coordinate the entire project, organize the work between teams, manage deadlines, and ensure that all subsystems move in the same direction. We work together with the university coordinator, who provides academic and institutional support, and with our technical advisors, who guide us through important engineering decisions and design reviews. The team is divided into several subsystems. The autonomous and navigation subsystem is responsible for perception, localization, path planning, and autonomous movement. The science subsystem focuses on the mission tasks such as probing, sampling, and handling scientific data. The structure and mobility subsystem develops the rover's mechanical design, including the chassis, suspension, wheels, and steering system. The telecommunication subsystem manages the connection between the rover and the ground station, including commands and telemetry. The electrical and power subsystem handles the batteries, wiring, power distribution, electronic integration, and electrical safety. Besides the technical teams, we also have the media and design department, responsible for branding, visuals, presentation, and social media, and the business and fundraising department, which focuses on sponsors, partnerships, and financial support. Each subsystem or department has a dedicated team lead, who communicates with the project manager and helps coordinate the work inside their team. Rover team is composed of students specialized in robotics, embedded systems, mechanical and electrical design, and software engineering. The reason we are participating in the European Rover Challenge is to apply our engineering knowledge in real, complex projects and to develop a rover capable of performing realistic space robotic tasks. ERC also helps us grow our local robotics and aerospace community. It brings students from different technical fields together and gives us a clear goal: to design and build a real rover system.
Hello, I'm Flavio, I'm Structure Subsystem Lead, and I will present you the Rover.
This is a Rover. It uses a rocker bogie mechanism for the suspension. It has 6 wheels for driving, out of which 4 can steer. All of the motors, both the driving and steering motors, have embedded encoders into them, so we can control them in a closed loop environment and know if the rover gets stuck on something and what position it gets stuck in, so that way it can autocorrect itself. Here at the front of the rover, the robotic arm is mounted. It has 5 degrees of freedom and will be used in the maintenance, astrobio, and surface sampling tasks. Here at the back of the rover, the drill is mounted. It will be used in the deep sampling subtask.
Hello, my name is Stefan. I'm a member of the electrical subsystem, and I will present you the electrical and control parts of our rover. For the electrical power, you have 2 main buses, one for the low voltage for the logic control units and one for medium voltage for supplying power to the motors. The navigation is based on computer vision, and the main processing board is a Raspberry Pi 5. As a safety mechanism, we have an emergency stop button that cuts off power to the entire system. For the telecommunications part, the telemetry, manual control, and live video feed are transmitted on 5 GHz Wi-Fi, and as a fallback mechanism, we also have communications on LoRa, transmitting telemetry and manual control.
Our drone is built on a rigid 7-inch carbon fiber frame, driven by powerful brushless motors and fueled by a custom-built 6S lithium-ion battery that guarantees extended flight times during autonomous operations. For control, we use a split architecture. Low-level stabilization is handled by the onboard flight controller, while complex navigation is offloaded to our base station running MATLAB with data streaming seamlessly through Express LRS. To tackle GPS-denied environments, we've integrated an optical flow module paired with a LiDAR sensor. This ensures precise altitude measurement and gives the drone full translation and rotation control across all axes. Safety and situational awareness are our top priorities. We've equipped the frame with high visibility LEDs that clearly signal to the current flight mode to the team. During autonomous operations, our system includes a manual override switch, allowing a licensed drone pilot to instantly take back full control of the mission if necessary. As an ultimate failsafe, alongside our auto landing and emergency landing protocols, we have a dedicated safety button that immediately cuts power to the motors even in mid-flight.
We also want to say a big thank you to our sponsors and partners. Their support helps us turn this project from an idea into a real rover and give us the resources and motivation to keep moving forward. We are really grateful for their trust in our team and in what we are trying to build.